Okay, this is the video lesson for 1.4, which is rational expressions. And before we do this one, I do just want to say, if you don't know how to factor, especially like the most basic factoring, this is going to be really tough for you. So I would encourage you to get some tutoring on the factoring if you're having a hard time. All right, so before we really go much further, I want to talk about the difference between an expression and an equation. Equation, you solve for x. Expression, typically you simplify. So this is what we're doing today. We're not really solving, we're just simplifying expressions, okay? Rational, we know that rational means ratio, but I just want to go ahead and give you some more formal language on what a rational number is. It can be positive, it could be negative, and I'm going to write this as P over Q, and this is typical language of writing a rational number, and P and Q here must be integers. It could work out for certain fractions for this to work out, but simplified all the way down, P and Q have to be integers or whole numbers. But again, it can be positive or negative. Okay, so like I said, we're not solving for x, we're simplifying. All right, so in simplifying, let's just jump into an equation, or jump into a problem. So let's say we had x squared minus x minus 6 divided by x squared plus 2x times x cubed plus x squared over x squared minus 2x minus 3. Now we have two different rational expressions here, and we're multiplying them, all right? And so what we want to do here is we want to factor. We don't want to multiply all this out and then try to do long division, because chances are that's going to be way too long, and we may even get stuck where we can't even finish the problem. But if we factor, it's much easier. So let's think about this first expression. Okay, this is what I was saying. We're not going to do the grouping method on any of this. We're just going to go straight into. So let's think about the factor pair of -6 that adds to -1. Okay, that's going to give you -3 and +2. So this should be coming pretty quickly to you now. All right, on the bottom, all I can do is factor out a GCF. That's going to be x, and then I'm left with x plus 2. Okay, I see something I can simplify, but I'm going to hold off for just a minute. Okay, up here, I can factor out an x squared, and then the other factor would be x plus 1. And then in this denominator, I know that this is a trinomial into two binomials factoring. The only question is, what are these two numbers? And that comes from what is the factor pair of -3 that adds to -1. So that's going to be -3 and +1. And of course, you could put +1 and -3. Okay? So at this point, this multiply right here, if this had been add, way more difficult. This is multiply. So it's almost like I could do this. That means any factor in the numerator can cancel with any factor in the denominator. And the reason we can do that is because an expression divided by itself is a 1. All right? So this x plus 2 goes with that. In this case, we have that. So these two things could have simplified individually on their own. You could definitely take something like x minus 3 and cancel it here, again, when you're multiplying. And the only thing I'm left with is x squared divided by x, which this is like xx divided by x, so it ends up just being an x. Now, if I asked you to graph, would you rather graph y equals x or y equals what I gave you? Obviously x. Now, I have actually, the graph would really actually change because there are some asymptotes at work or holes and things like that. But in terms of where you go with this in calculus, this is why you want to be able to simplify, because sometimes it simplifies quite nicely. Okay. All right, so let's talk about the next example. Example 2. I have x divided by x squared minus x minus 6, that's my first expression, minus 1 over x plus 2, and then minus 2 over x minus 3. Now I have 3 expressions. I'm adding, well, in this case, technically subtracting. And remember, with fractions, you have to get a common denominator. Well, the nice thing, and this almost always happens when you have 3, this one right here does factor. I'm going to go ahead and write it as x plus 2, x minus 3. Now, you would want to check that, but that almost always happens, and it did happen in this case. Okay? So what I'm going to do is I'm going to write all 3 expressions in terms of that denominator. X plus 2, x minus 3. And if you try to skip this step, you're likely to make a mistake in the next round. So just write it out. It's not that difficult to do. Okay, the first expression doesn't change at all because that was the denominator you started off with. The second one, though, there was a 1 in the numerator. You multiplied the denominator by x minus 3, so I need to multiply the numerator by x minus 3. Okay, in the third term, I had a 2 already, and I multiplied the denominator by x plus 2, so I need to multiply the numerator by x plus 2. Okay, now that I have all of these as the same denominator, I can write them as one term, or one expression, really. So then I have x. This minus applies to everything. So it's almost like you're distributing the minus. So I have minus x plus 3. Same thing here. Minus 2x. Minus 4, because the minus and the 2 are distributing. And so let's simplify. So here I have x minus 2x. That's negative 2x. 3 minus 4, that's minus 1 or negative 1, over x plus 2 and x minus 3. And you need to simplify your final answer. So what you need to think is, can I factor the numerator? And if so, is one of those factors going to cancel with the denominator? If you can say with certainty that even if you could factor, like in this case, I could factor out a negative 1, but is that going to help me simplify? No, leave your answer the way it is. Okay, now I just have one expression instead of several. Okay, the next problem I'm going to write maybe gave some of you nightmares back in pre-AP Algebra 2. And we're going to talk about ways to solve this. So I got a minus b over a, and then minus a plus b over b. And you wish that was it, but it's all over a minus b over b plus a plus b over a. Now, one way you could do this is to simplify the whole numerator all the way down, simplify the whole denominator all the way down, and then divide the two terms by multiplying by the reciprocal of the denominator. And in a lot of problems, that is how you do that. But I see a lot of common terms here, so I'm going to be clever about this. Okay, I'm going to find the least common denominator of the numerator and the denominator, and in this case, they happen to be the same thing, AB. And that's what I'm going to multiply by. Okay, so let me write this out here. The LCD is AB. So I'm going to multiply the numerator by AB. And the fact that it's the same for the numerator and denominator is essential, because if you multiply the top and the bottom by the same expression or number, then you get an equivalent expression. I couldn't have multiplied the top by AB and the bottom by just B. That would not have worked. So this technique would not necessarily be that helpful in every problem, but in a problem like this, for sure, it would be. Okay, so let's multiply here. Now think about this. If you multiply AB times here, we could distribute AB, then factor, then simplify. But think about AB in the numerator over A. What is AB over A? It's just B. So we're going to be really multiplying B times A minus B, and I'll actually distribute in the next step. Okay, likewise, in the next one, minus, okay, AB over B, I would be left with just A times A plus B, and I'll distribute in the next step, and you can see, predict that things are going to simplify. All right, this next one, AB over B, I would be left with A. It kind of just goes to show that the more clever you are in math, the less math you actually have to do. There's kind of an expression that says the best mathematician is a lazy one. He finds, or she finds, the easiest way to solve a problem. All right, so here let's distribute. And instead of BA, I'm going to go ahead and write it as AB. That way it'll be easier to simplify. And then minus B squared. Over here I have minus A squared minus AB. So I can see that those two things are going to cancel to 0. In the denominator, I have A squared minus AB, and then plus AB plus B squared. Okay, so those two terms cancel to 0. Let me write what I have left, and then we'll see what we can do about it. So do you remember what I said about factoring? It's not so much that you have to factor, it's that can you factor to make something cancel or simplify? And I'm going to factor out a -1 of this numerator, and I'm also going to rewrite it with the A squared first. Now look what happened. If I factor out a -1, then both of these terms become positive. And look what happens next. Okay, I'm going to put parentheses around this just to make it clear. A squared plus B squared, the whole thing cancels with this whole thing. I cannot cancel the A squared with A squared and then the B squared with B squared. It doesn't work that way. It's this whole term cancels with this whole term. And this whole thing simplified to just -1. And even though you may think this is a lot of work, it was so much more work to simplify the numerator, simplify the denominator, then divide by multiplying by the reciprocal, and then simplifying further. That would have actually been more time consuming. Okay, one more example. X minus the expression y divided by x over y plus y over x. Now again, you can do this by simplifying this whole term and then getting a common denominator, but what I'm going to encourage you to do is kind of focus in on this and think, okay, can I do what I did on the last problem? Can I be clever, multiply numerator and denominator by something so that I can narrow down at least the number of fractions that I have? Okay, so look at this denominator right here, y and x. That's what the LCD is. So I'm going to multiply x, y, and if I multiply both the top and bottom by x, y, I haven't done anything but just rewrite it in a different way. It's an equivalent expression. Okay, this x minus is still just going to hang out for the time being though. All right, so at the top I have xy squared. However, in the denominator, again, y over y, that cancels or becomes 1. X times x, that's x squared. And then similarly over here, x over x, that cancels, and then y times y is y squared. Now I still have two expressions, but at least I don't have a fraction within a fraction, okay? So now I get to get a common denominator. Since the first term is not written as a denominator, we'll just take the denominator of the second term and use it for the first. That is our least common denominator of these two. So since I multiplied the denominator by x squared plus y squared, I have to multiply the numerator by that. And you can easily see as you go on that I've written an equivalent expression. I can easily cancel out these two terms and see that it's equivalent to x. Okay, this one over here, though, didn't change because that's what the denominator was. Okay, now I'm ready to go ahead and write this as x squared plus y squared, just one expression. X times x squared, that's x cubed. Just thinking about distributing, this becomes xy squared. Then I have minus xy squared. That worked out nicely because those two cancel. And I am left with x cubed over x squared plus y squared. And if you're thinking about canceling these two out, stop. This plus connects. I can only cancel this x squared if I have something exactly like this term. I don't, so you cannot go any further. Okay, this is your answer. If you try to go any further, it's a mistake. Okay, bring your questions to class.